Hi guys, in today's video we will focus to async email sender. In previous part we created simple email sender with Spring and with SendGrid. We also added persisting option, so our email messages are persisted in PostgreSQL database. Now we will try to make it async. First of all, let us try to understand what async means. Currently, when I call this endpoint, it calls this service, and this service is calling another service, and it is immediately sending the message. It is happening everything in foreground. It means that the request should be waited until the email is sent. If the email sending process takes longer, let's say it's taking 10 seconds, 20 seconds, 50 seconds, the request sender should wait. Yeah, it has some disadvantages. First, let us try to understand what is the problem with current implementation and what is the purpose of doing it async and what we will have as an advantage by implementing it in async way. Let us write down these pros and cons. For this purpose, I will use our notes. The first most important pros are client or our API consumer, whoever uses our API must wait until email is sent. You can say that what is the problem with that? Yeah, the API consumer can wait, but the problem is our API consumer, our client, is waiting for some action which is which is not in our control. So we are out of this control. For example, it is possible that this email service is down, or it is responding late, or for whatever reason, we can respond to our API consumer in a late time. The second problem is, let's say it's okay for API consumer to wait. What else problem we have? The second problem is we are using Spring threads for sending email. As you know, Spring Boot has a limited number of threads, and this thread is supposed to be working with Spring Boot application. They are not supposed to work for some long operations. So we are using these threads for sending email, and as sending email is an external service, and it might be there are possible risk it will take longer. Let's say if we want to send 100 email, and if our email service is down or is responding late, in that case, if we have 200 Spring managed threads, after 200 thread is filled, the API consumer will not able to reach our service. The API consumer will not be able to reach our service because after 200 threads is filled, our incoming requests will not be accepted, and API consumers will start to wait. Of course, we can increase these threads, but if we even increase these threads, one day they will be filled. We don't have any buffer mechanism or any mechanism to guard to help API consumer handling mechanism. It is the main problem. The third problem is API consumer. Actually, it is not most related to API consumer, but we don't have any recovery mechanism. As API consumer is calling the endpoint, this operation can fail, and we will immediately, let's say after one second or 20 seconds, we will return an error to API consumer, and we will say that we cannot send the email. Let's say the email service is down, but we don't have any recovery mechanism. If we do it async, if we do it in background with another thread, we can build our recovery mechanism. Like if the email wasn't successfully sent, it can retry after 1 minute or retry after a while. It means that we don't have any proper control on executing these actions if it is synchronous. And the problem with HTTP is its protocols are we cannot make the API consumer wait long, because let's say if we implement a retry mechanism with client approach, it can force API consumers to wait even more. So it is not good. As knowing these problems, let us try to implement it in an async way. The idea in converting some foreground operation to the background, or some sync operation to async, it is very simple. The actual execution is here. Instead of executing this action inside create, we will not do it here. We will do it after inside some loop or inside some another thread. We have a couple of ways to implement it in an async way. I will only explain you only 2 or 3 of them, but there are also multiple ways to implement it in async way. The first easiest way is we can use thread pool or execute a service, and we can immediately call it. It is easiest way. But the problem with this approach is we make it asynchronous, but we don't have good control on it. I will explain what is the problem with control later on. The second option is we can store it in database, which we are already doing, and another thread can get from DB and execute. It is most likely a task scheduling principle, but it is not a full task scheduler, but it is some kind of email message tasks, and we are storing it on the database, and after that we are grabbing them and we are executing it. And third option, we can use message broker, or we can use message streaming. It is also some kind of message broker. Mainly we can use RabbitMQ, or we can use Kafka, or we can use any similar mechanism. And the third option is called streaming option, and second option is called batch option. Let's name like that. And this option is just executing in parallel. It is, I don't know any name for it. Okay, so first let us try to by the way, in this video I will only cover first two. For streaming option I will focus in part 4. So let us start with very simple option, first option. And after that, let us understand what is the problems here and why we will go to second option. Yeah. Let me find our series. Let's say we created 20 threaded executor series, and here instead of executing it directly, we are adding it as a task here. Yeah, it is very easy, but it is async, but we have some problems here. Let us understand what is the problems. I will open the notes in the right tab, and we can have a notes in parallel. Normally it should work properly, but let us understand what will happen to this executor service if it is under load. Let's say we have 1 million, or let's say 100,000 emails which should be sent, but our email provider cannot send this amount of emails currently. Let's say we have unbalanced peaks. In peak time, let's say maybe in morning or in afternoon, we have too many mails which should be sent. And but in later hours, we don't have that much email. And for some reason, our email provider, for small period of time or for long period of time, for unknown period of time, cannot handle this bulk operations. This problem is named back pressure problem. What is the issue here? If back pressure happens, our executed service will be filled. And normally, when executed service is full of tasks, executed service can do one of these three options. The first option for executed service for thread pool is to accept and keep it in memory. Let's say if our executed service can accept infinite amount of tasks, it will keep it in memory. Basically, we can have limited, it is using limited blocking queue, but if this limited blocking queue doesn't have any capacity limit, it will just add, and the problem is our memory will grow, and it will use a lot of memory, and our application most probably will be crashed. Another problem is, let's say in some cases our application will not crash, because let's say we can give 6 GB, 10 GB of memory, and we can hold even more messages in the memory. The problem is now the messages are inside executed service, inside our memory, and if our application crash anytime, let's say if it even crashes once in a 10 days, a lot of emails will not be sent, and we will not know that if this email is sent or not. The problem is there are a lot of things under control of executed service, and it should not be like that. The second option is it can use limited queue. You can find implementation of limited queue in the Google. The limited queue is forcing executed service to wait when it is filled, when it is full, and you can apply some limitation here. The problem is after our executed service is full, it will force Spring Boot threads to be full, to be overused, and it will cause our applications to stop working, to stop accepting any request. The third option is executed service can reject the incoming task if it is full, which is not good. But besides this option, we don't have any good alternative here. What else we can do? As you see, you saw the problems with simply using thread pool. We can go to second option. In second option, instead of sending this message immediately in async, but immediately, we will send it not immediately. We will send it with some scheduling, but we will do it in background. And let's see how we can do it now. First of all, before implementing it, let's add one field here, and it will be our status of this email. Email, message, status. No need to forget that. Let's say it will be pending, sending, sent, and failed. I will make it create. Yeah, the route is already create. Now, let's just create another service. Email, message, sender, not sender, email, message, scheduler service. Let's enable scheduling in Spring Boot. Let's say for every second, for 1 second delay, we want to call this endpoint. Here, first, we will find all pending emails. After that, for each of item, we will update its status sending and no. And after that, for each of it, we will call send email. Yeah, we need to convert it to the detail. We need to implement try catch here. Yeah, if any exception happens, we will log this exception. Why we are catching all exceptions, not specific exceptions? The reason is we don't want, if any kind of problems happens inside this send email method, we don't want to crash this thread, or because it should be every time, it should work always. Let's say if for some kind of fault, if our scheduler stops working, the email service, this application will be useless. So we cannot allow any kind of problem happen here. Actually, we can even add try catch to there. Yeah, and it is okay to keep two try catch nested. Let me explain why. The reason is, if you don't have this try catch, and if some errors happens here, which is very possible, in that case it will stop working here, and we will, let's say we have 1000 email in our hand, we will lose it and we will get this 1000 email again. It doesn't make sense if some problem happened because of sending email and to get everything, to start everything from scratch. For that reason, I think having two try catch nested is better option. As we do it now, afterwards, after sending the email, we can update the status again to send. And here we can make it failed. And let's save entity into place, first here and second here. Okay. Now everything is okay, everything seems like okay. We can test if how it is working, and hopefully it will work. Let's see what happened here. Send your message. Okay. Let's see what is our data, what we have. Yeah, the status is now. It is a problem. Okay. We need to set the status to the pending. Yeah, it's sent. Now we receive the email. So it is working, and it is all async. Yeah, that's all. We covered async mail sending in this video. We will continue bulk email sending in next part. So thank you for watching.